Thank you for coming. This is really exciting. I've been having a great time this reInvent. Have you guys having a good time? Yeah? Cool. Thank you. I'm with the Alexa team, and part of the reason I've been having such a great time is I love being surrounded by people who build stuff. Like the creativity that's happening here is insane. And I think that's kind of what powers the world. It's what makes really cool new things happen. And when you couple that with sort of where we are in the world, let me just start digging in here. I'm gonna skip my overview slide and I'll come back to that in a minute. When you couple that with that sense of creativity and the ability for people to build stuff with what's happening in the world right now, it's really interesting space. So I'm particularly coming from a voice UI kind of mindset. And if you think about the stages of user experience that we've had over decades, it seems like every decade or so there's a new model coming out. First it's like I'm typing using DOS, and then I've got Windows, and then I'm using the web. I've got information everywhere. If you think back to sort of 2008-ish kind of time frame when you first had the web in your pocket, you're like, I can carry the web everywhere. And it's this magical moment, right? You're like, this is really, really cool. It was also kind of rough because the best design practices of the day were not designed for a touch device that's tiny and all that kind of stuff. So things like hover menus, they were awesome on the web. Everybody had one. Woo, things are flying out. But on your phone, you're like, I can't get, how do I get to the menu? It doesn't exist. Other things were, hey, if you bought a really big, expensive, high-resolution monitor, how much of a bummer is it that you don't have more stuff on your screen? So people who are spending a ton of money should get more stuff. So we need palettes of controls and all these things. Don't give me any blank space. On a phone, a really high-resolution screen does not mean more stuff because your finger is still 7mm tap target, right? So it took the industry to figure out, what does it mean to do touch? What does it mean to build things like we now call responsive design, but at the time, we didn't really know and understand. And who did that? Who figured that out? It was the indies. It was the people who had nothing to lose. They were bold and brave, and they pushed out into the new world, right? It was people like Angry Birds and Rovio. And they said, we're not going to build a game that has a power up button and a power down button and an angle up button and an angle down button and a shoot button. That'd be boring. Got that. They're going to do a slingshot metaphor. They're going to touch and drag, and then you let go, and everybody's like, what? Like, that started gestures, right? We have this sense of like, how do you get things built? So that's why I come back to I love this kind of environment. Super creative, crazy people trying to do really cool new stuff. And it happens in software. It happens in music. We don't listen to the same music that we did 10 years ago because of these folks, right? Because of you. Just last night, we ended the Alexa Skills Contest. I don't know if you guys heard about it, but there was this contest going on throughout the whole event. Had a $10,000 prize and a bunch of Echoes we're giving out. The people there built mind-blowing stuff while going to sessions and staying up late. They were like, I didn't go out and party last night because I was up till 4 coding on my Alexa skill. And I'm like, that's awesome. But there were some crazy ones there. The one, I'll tell you a few real quick. There was one it was by Chaos Monkey. And so the idea is you have your Alexa sitting here and you got your whole infrastructure up and running and you say, Chaos Monkey, go! And then knocks out a random number of EC2 instances out of your system. You're like, what's going on? Another one was pager duty. It's 4 in the morning, your pager goes off, and you roll over and you go, Alexa, what just happened? And it'll tell you what's happening. You can go, escalate that, or okay, acknowledge, and you can move on your way before you even get on a keyboard, right? Just like back to work of sleeping. There was so many cool ones. There was another one where it was monitoring what your baby's doing throughout the day. And so you would tell it things like, oh, my baby just ate some food. My baby just took a dump in his nappy. That was one of the phrases that you would say. And so you could track what's happening the whole time. Anyways, cool. The one that won was this one where they had a webcam over their crib. And you could say, Alexa, is my baby asleep or not? And it would tell you if your baby's asleep using vision recognition. Which is really amazing. You can imagine the application of that, like, is my package here? Did the kid leave the bike in the front driveway? All sorts of things. Who came over today? would be an interesting scenario like that. When did the housekeeper leave? Like, I don't know. You could do all sorts of things, but it was a really kind of amazing thing. Okay, so given all that, indies are cool and awesome. One of the things we want to talk about today is this skill called Magic Door, and Andy here is going to come up in a minute and talk about what he did to build this. And what I love about this is, first of all, it's fun and engaging, but it's also deep and technical. Like, they've really gone through figuring out what does it take to make this happen. Like Rovio had to say, performance really matters, because if you touch and you start dragging that slingshot and it doesn't stick to your finger, people are going to have a really bad experience. Because with the mouse, whatever, you might not even notice it. With phone, you got to figure it out, right? And so that's a lot of what's happened here, and I think there's a lot of really cool things we can learn that are going to push forward what UI design might be like for voice. So I'm going to give you the slightest little overview of what it takes to build a skill, and then we're going to go into all the crazy details, okay? All right, so at the heart of it, Alexa skill is the customer says something to Alexa, and then Alexa starts responding and doing things. So we call those utterances. So here's an example one. You'd say, Alexa, ask Skill Master, what are skills? So this is, Skill Master is a skill that would help you understand terminology like utterances, slots, intents, or how to build things, like how to use SQS or IoT to communicate with Unity and control VR and that kind of stuff, right? So the way this breaks down is Alexa's the wake word. You can say Alexa or Amazon or Echo. By default, it's Alexa. And then there's this launch word, which just makes it more natural. You can say Alexa ask or open or tell or begin or start, that kind of stuff. And then you have the phrase, the utterance. What are skills? Now, when you're designing for a website, you have a button and it says something like OK. And that's it. There's OK. And you click it and it does OK. In voice, the customer might say OK, but they might also say, Roger that, got it, next, continue. Like they could say all sorts of things. So part of our job as UI designers for voice is to train them on, or to train the natural language engine on what they could say. So for example, they could say what are skills, but they could also say, tell me more about what skills are, right? Which is also a great other way to phrase this. So what you do is you build out a series of utterances. Those utterances will then resolve to an intent. So no matter how I say that, in either of those two ways, I would get back a definition intent, and your code will get that, and then it also gets the slot value, in this case skills, because I could be asking about other things, right? I could be asking about what are utterances, or what are intents, or what is a tap, or what is a dot, right? Okay, so what's happening there? The first part is you have to train our natural language engine, and you do that by providing some sample utterances. You don't have to be fully exhaustive. What you're really trying to do is get approximately the right thing so that it matches really well. It resolves it back down to this intent. You send it. Now it's your job to process that and do whatever you do. Whatever you do when you want to give a definition. You'd go look up based on your skill. Maybe it's a key value pair lookup as for this kind of a scenario. And then you return that back to the customer, and then Alexa will use text-to-speech to convert it back into sound, and then we're on our way. Okay? So that's the general high-level part of how it works. What you explicitly don't have to do is build natural language processing. You don't have to build the speech recognition stuff or any of that, right? This is your training Alexa how to deliver the right intent. Okay, so with that, I'm going to bring up Andy, and we're going to talk about the Magic Door. So I'm really excited. Let's give him a hand and come on up. All right.
Thanks, Paul, for that great intro. So you remember when you were kids, and you probably read a lot of books, maybe somewhere about fantasy, like castles and knights and princesses and things like that. And some of those books, maybe, you just keep reading, it's a chapter book, you get to the end. It's a great book, you love it. But some, on page 2, you're faced with a choice at the bottom, and it says, would you like to fight the dragon, or would you like to go search for more weapons? And then your answer to that question dictates kind of the rest of the story. And then you can keep making choices, you can go back and you can change your choice and experience the story again in a totally different way. So about a year ago, my wife and I were like, hey, what could we build for Alexa? We had this idea that we could build an interactive adventure like that, but powered by voice. So it wouldn't really be the same thing as just what you read in a book, but it would be kind of like something totally new because of the new capabilities that you get with a voice ecosystem. And so that's kind of like where the Magic Door started. And a little bit about me, I do work at Amazon, but this is like totally side project. This is something I do with my wife at home and my kids. And so we've just been working at this over the course of the year. So let's talk about what is the Magic Door. So as I said, it's an interactive adventure. And it turns out about 6 months ago, we kind of built enough of the Magic Door that just telling our users what are all the things you can do became challenging. And we just, there was so much stuff and people couldn't discover it. So we kind of drew it out on a big map like this one here. And so you can see that, we have all these places that you can go and explore. We have mountains, we have a dragon, we have a wizard tower, we have a temple and a tropical island, we have a castle where you can save a princess. We have all these things, and you just explore the land by making choices by voice. And we kind of lead you through. We have sound effects and voices, and you'll hear some of that in a minute. In fact, I believe you'll hear that now. Okay.
Alexa, open the Magic Door.
Welcome back to the Dark Forest adventure.
We walk through the open gate and find ourselves on a cobblestone driveway leading up to the big house. The house is dark except for the single light shining through the third-story window. As we approach the front steps, a spooky fog moves around us.
He's in there.
What? Did you just say something? Wait. Look. Did you just see that? A figure moved past that third-floor window. Someone's up there. Let's go up the steps and knock on the door. We walk up to the massive wooden door. I reach for the door knocker in the center, but before I touch it, the knocker knocks all by itself. The door opens just a bit. We both look at each other. Do you think somebody's in there? Should we go inside? Stay outside? Or get out of here?
Go inside.
Okay. I push the door open more. We peek inside. It's pitch dark. We can't see anything.
Is anyone in there?
Okay.
It's...
So that's what the Magic Door sounds like. So you can see we do kind of, the user makes some choices, but we tell a story. And we tell a story using Alexa's voice, using sound effects, and using character voices. And I believe that's the first time Alexa has ever whispered, like Alexa has ever whispered in any context. So that's something we think is kind of cool. So if you were to, instead of kind of drawing it out, if you were to kind of chart out the whole Magic Door land into like where could you be and where could you go from there, it would look like this. And so we have these scenes where users could be, and we can do a lot of things in each individual scene, but then also you can go from scene to scene, and those are the choices that you make. Some statistics. So we started more than a year ago. I mean, we're one of the pretty early skills. We launched in February. We've made more than 100 production code changes in that time. We'll talk about how we do that. 11 versions of our skill have gone through the Alexa skill certification process. We've gotten more than 3 million utterances from customers, from 80,000 customers, who have completed 60,000 adventures, picked up 60,000 items-ish, around there, given us 144 reviews, about 4 stars, and we've gotten 627 Facebook likes at Alexa Magic Door on Facebook. So some of our reviews that we love are this one, like, love it, brilliant, I love this, it reminds me of a book I had as a child. And another one that says, best Alexa skill, there is so much detail in each story and the number of different options is great. So if we'd sat down and written our own reviews last November when we started, this is pretty much exactly what we would have liked, this is what we could have imagined we could have accomplished. So we're pretty happy about that. Now, of course, they're not uniformly like this, now, and they certainly didn't start out like this. When we launched, they were kind of more like this, more uniformly like this. This is super fun. However, there are not many adventures that it gets boring. So this talk is kind of about how we went from boring at launch to kind of the other reviews, sometimes at least, and that's one of the things that we'll talk about here. Another thing we'll talk about is that Alexa has gotten, the Magic Door has gotten to be a reasonably complex system over the last year. It didn't start out like this. It just started out with that like one box in the middle and not much code. But over time, it's gotten to be, reasonably complicated. 5,500 lines of JavaScript, more than 5,000 lines of XML at this point. It does run on less than $10 a month in AWS usage. And we also have a little bit of Scala code at this point for analytics. So we're going to walk through kind of the full life cycle of how we built this skill. We're going to start with just how do we release the first product, how do we deliver future changes, how do we continuously deliver changes to our customers, how do we test our changes before we release them to customers, and how do we consistently on a weekly basis make sure that our users are having a good time from a operational perspective, from a story perspective, et cetera. So the way it turns out that many successful skills, or all the ones that I'm aware of, kind of start by working backward from the customer. And what that means is, this is an Amazon thing, at least, and probably everyone else does this too, but this works pretty well for voice skills right now. This is what we did. So we started with an idea, and then before we wrote any code, my wife, who writes all the stories, I don't write the stories. It's really my wife. I just write a little bit of code. So she sent me a script. She's like, here's the story we're going to tell. How could we build this? And so that's kind of working backward. We don't know how it's going to work, but we know what the experience we want to give to the user will be. And so she literally sent me this. It was in an email. And so we just worked through this, and we tried to figure out, what is this, and how could we build it? So it starts with Alexa, open the magic door. And then it says the door is open. In front of us are 2 paths, etc. Would you like to take the forest path or the garden path? Then the user says garden path. And then we respond with, OK, follow me into the flower garden, etc. So we kind of tried to work through this. We saw this first part. It's a launch phrase. Every Alexa skill has a launch phrase, or a skill name and a launch phrase. And so what this means is that our skill name is the magic door. So open the magic door. That's what users always say. Then the next part is this thing. The door is open, in front of us are 2 paths. That felt to us like the description of where the user is right now. We thought we would probably be doing this a lot. We call that a description. Then this next part, we call this a prompt. If you're building a skill and you want to continue interacting with the user, you kind of always have to ask them a question. So we call that a prompt. We have to give them some kind of prompt. Then together we think of this as a scene in our story. So we're describing to a user where they are right now and what they could do. That's a scene for us. This next part is kind of interesting. We think that the user makes a choice, and a choice is followed by a transition into a different scene. Not much magic in this kind of breakdown of the script, I must say. And there's not much magic in what happened next, which is that we just turned those concepts that I described into an XML syntax for describing stories. And we have a DTD, it's right there. The XML that we wrote is kind of exactly the same concepts that I just described. We have a story. Stories have scenes. Scenes have transition, description, and prompt. And they also have multiple choices. Choices have intents, which is what the user speaks. And they have transitions and destinations. And that's really exactly what you saw in that script before. So we went from, we just wrote something down to a formal description of what a story is. But this doesn't tell us anything about how we're going to implement this thing. And so this is when the coding started for us back in November, when we tried to figure out how are we going to implement this XML syntax for describing stories. And so now we had to solve 3 problems that all skill developers have to solve. You have to recognize user speech, to manage conversational state, and you have to produce output speech. So just to remind you of the basic model for building a skill. User speaks. Alexa understands their speech and presents it to the skill by turning it into a structured representation of what the user said called an intent. And the way that Alexa knows what intent to produce for a given user utterance is that as a skill author, I've given, as Paul was mentioning earlier, an interaction model to Alexa that is specific to my skill. So I say, when the user says this, here's the intent that should come out. Here are the slots in that intent. Here's some sample utterances. So that's the basic model. So for us, it turns out that if you're building an interactive adventure, you don't have just like a couple intents that users are doing. Like, some skills that are reasonably, like many skills have only a few intents. If you're building an interactive adventure and users are using natural language to walk through a story, you're going to end up with like hundreds of intents, and we do have hundreds of intents. So actually, we don't just write out our interaction model and copy it into the developer portal. We actually we basically like compile, or we build our interaction model by combining all of the intents from the different stories together with our global intents. And then we do have like one big old file where we have all of the sample utterances for all the intents. And then together, these hundreds of intents, story-specific intents, global intents, we compile basically the interaction model that we then stick in the developer portal. And for us, again, kind of unlike a simpler skill, we have some challenges just with respect to we have a lot of intents. I mean, if you have like 4 intents or 5 or 10 or something, then what you should do is you should spend a lot of time thinking of like every possible way a user could express those 10 intents, because that's your whole application. That's what everyone's doing. For us, we have some intents that are used widely throughout our application, like by many users, like the hot scenes, the global commands, like talking about inventory and things. And on those, we do exactly that. We spend a lot of time thinking about like, hey, what are all the variations? What are all the different ways people could say this? But then we have hundreds of other intents that are used like in one scene. And what the user should say to express that intent is really dictated by the prompt they just heard. And there's not a lot of variation. So we come up with this kind of like, this kind of gradation of how much time we spend on any given intent. And for us, so we have complex or frequently used intents that we spend a ton of time on. And then we have simple and infrequent intents where we can get away with just specifying a few different samples for that utterance. And that gets our users kind of through the story. So now that we've understood what the user is saying, like what did they mean to say, to do in the story, then our next problem is to manage conversational state. And what this really means is we need to make the right thing happen in the story, given what the user said. This is a common problem faced by pretty much all voice applications, it turns out. It's really, it's like a core dialogue system problem. And it's a very well-studied problem, like academically over 20 years of building voice systems. And there's a lot of ways to do this. Some of the simpler ones are like you can model your dialogue as a state machine. Others are like, well, in many applications, what you're really trying to do is you're trying to help the user complete a task. So what you can do is you can model your dialogue as kind of a task tree. Like here's the overall task. Let's break it down into subtasks. And those tasks are your conversational model. And sometimes they're trying to fill out a form. So the form elements and filling out the form and making sure that each form element is correct, that's a conversational model. A lot of ways to do this. Some involve machine learning, like finding the most likely and the fastest way to get the user from where they currently are to their goal. Some involve machine learning to help understand when errors are occurring in the dialogue so that we can help the user get out of an error condition where they don't understand what's going on. So it's an ongoing problem. You can pretty much work as hard as you want to on dialogue management, but there are also simple approaches. And understanding kind of this problem at the beginning, we went with a pretty, so those are all the possible solutions to the conversational state problem. And as a skill developer, because of the stateless model of Alexa, where you just get the next intent from the user, as a skill, you have the opportunity to use kind of whatever of those approaches is most relevant to your skill. And for us, it turned out that, hey, let's go back and look at the graph. For us, a state machine-based approach made a lot of sense because actually it fits our graph, like our story graph, very precisely. In any given place in the story, we know what your current state is. It's, we drew it out, it's in our script. It's clear that you do have a current state. And then it's also clear that certain choices are legal and many other choices are not legal at this time. And so you can think of the state machine as, like the finite state machine as, each of our scenes is a state, and each of the intents that a user could express that is legal and leads to a different scene, that's a transition that's allowed in the state machine. And all the rest of them are not legal transitions in the state machine. There's no edges between those two states. So we can apply that like known dialogue management approach to our story, which is what we did. And it's actually really simple to implement this because the state that we store is just the story ID and the scene ID of where the user is right now. And we just stick that in a Dynamo table. It's 2 attributes, and we're done. And we key that by user ID, and that's kind of the end of the dialogue management story. And this, that's the end of the dialogue story at the beginning. It has since become much more complicated because we have stateful scenes, we have choices you can only make when you have certain inventory items, and we have to factor all that in when we figure out whether your choice is legal and what the effect of your choice is in the story. But mostly it still does boil down to storing your current story and scene in a Dynamo table, and then given an intent, looking up what is an allowed transition from that scene, state to another state in the story, in that story XML I showed you. So now that we know, based on what the user said and our conversational model, what should happen, like is it an impossible choice or is it going to go somewhere else, what we have to do is generate speech. We need to generate speech output to the user. And so let's just kind of go back and look at the script a little bit. We can see these blocks here. The door is open in front of us are 2 paths. Would you like to take the forest path or the garden path? And we look at the XML, and we know that we won't always be generating just like these static blocks. What we're generating is actually kind of the combination of a transition, a description, and a prompt, and it's dynamic based on what the user chose. So it's not like we're just spitting out static text all the time. So at least we need to like concatenate some strings. That's not very complicated, but we also we have more interesting things to do. And as we're generating speech output from Alexa, the main tool that we have at our disposal to like control that speech output is this thing called SSML, which is Speech Synthesis Markup Language. We didn't come up with this. This is an existing standard for controlling the output of text-to-speech engines. What we discovered over a year of building this thing is that knowing SSML and using it appropriately is as important for us as voice application designers as knowing HTML, CSS, and JavaScript is to web developers. It's not as complete. There's not many techniques that you can apply using SSML. It's pretty simple right now, but you do have to take advantage of all of it to build a great voice experience. So let's kind of walk through some examples here and see how we use SSML to build a better voice experience. So we're just going to listen to it. Well, that sucked. Hello? I think I might be missing some things. That's really too bad. OK, so actually you heard this example. I think some of my samples disappeared. So sorry about that. OK. You actually heard this earlier. In this scene, what we want to do is convey as the sense that Alexa is experiencing a moment, like experiencing a scene with you as the user. And so if you, as Alexa, are, you're participating in the scene and you think that something mysterious is happening, you're not just going to read it off at full speed, and that won't create the right effect. But by using the SSML break tag, we can spend a little time in the scene. We can make it seem as if Alexa is experiencing that moment with you just by adding the pauses that as a human you would actually take in the scene. And you actually heard the effect of that earlier, it turns out, so we'll skip it. OK, so next thing that we do, we found over time that pretty much any time you can remove just words and replace it with sound effects or something, then the users get happier. It becomes more engaging. So here, this one actually I believe will work.
Oh my. Do you feel that cold wind? It sure is getting dark. We hear wolves howling. I don't like that.
Okay, so great. We understand there are wolves howling, but that was kind of boring, I believe. Maybe you agree. And but here's something that we do instead.
Oh my. Do you feel that cold wind? It sure is getting dark.
So
I don't like that.
the SSML audio tag is kind of one of these main things that we use throughout all of our stories to make them really, immersive or interactive or engaging. And we think that our users really enjoy this aspect. And we actually started building the Magic Door before there was an audio tag. And even for us, it just wasn't that fun. We built our stories and we're like, yeah, I don't think this is really going to work. But then, like the next week, the audio tag came out, and it just completely changed the whole story, how it felt, whether our kids wanted to play the game that we actually made, and basically it just completely changes the experience. So we use the audio tag all over the place. We spend a lot of our time building the Magic Door, making sound effects, replacing just static text with sound effects, and we're not like professional audio engineers, so we're kind of like pretty low budget on the sound effects, but even though it's recorded in our house or out in the woods in Seattle or places like that, our users really appreciate it, and we think it makes the story much more engaging. Okay, so another example, I hope.
Her ethereal face suddenly turns monstrous as she stands up and yells, "Everything is not okay. It's a nightmare."
Okay, so again, that is pretty boring.
Her ethereal face suddenly turns monstrous as she stands up and yells,
Now, everything is not okay. It's a nightmare.
So, that's clearly better. Users really like it a lot. So the Alexa TTS engine is a great TTS engine, and there probably aren't many. I don't think there are any better ones. But at the same time, just listening to TTS engine for a long, extended period of time turns out to be not that fun. So we break up string of TTS with sound effects. Anytime we can, we replace TTS with voices, and that makes all the difference in our application. And by the way, if you've listened to any of the other interactive adventures for Alexa, like the Wayne Investigation or the Baker Street Experience or some of those other ones, they're completely not TTS engine. And for example, the Wayne Investigation sounds really good. Like everyone who plays it thinks that is a fantastic experience, and it's all audio tag. So that's clearly a good way to go. But as on the web, just knowing your static HTML is not enough to deliver like a rich interactive experience to users. We all know server-side templating, client-side templating. You need to have some control over how you're generating the SSML that actually goes out to the users. And so for us, we built kind of a custom templating language for the Magic Door. It's a very basic one. It's kind of what we need. And it kind of looks a little bit like XSL, a little bit. But you can see here that we have the static SSML that I mentioned before, just text and audio tags and things like that. But then around that, we built this custom template language, this custom templating language with choose and when. We have this expression language, which is actually JavaScript. If the scene state matches talk to the GNOME, then we're going to emit this SSML. And otherwise, we're going to generate that otherwise thing at the bottom. You can have multiple choices. We don't yet have like dynamic substitution, but when we need it, I guess we'll do it. That's basically the plan there. So using SSML and a templating language, that's really how we generate the full Magic Door voice experience. And what we find is that SSML is not just useful for creating that engaging experience. It actually is critical to getting users to successfully use your application. we like obsess over every prompt. We like read it and we reread it, and we're like, are we sure that we're communicating exactly what the user can do in this scene? And it makes a huge difference when we get it right. So for example, we have this analytics system, which we'll talk about later. Not everyone does. It's a custom code just for the magic door. But if we were to like look at every scene and we were to say, how often are users successful in navigating the scene and doing what's supposed to happen here? We can, by using that chart, we can kind of drill into the scenes where users are failing. And in this one example, we had a scene where users were not able to, were failing and dropping out of the skill 20% of the time. So that's not that good. But by, and just to drill in a little bit more, that's what that 80% looks like. So we just changed some prompts, just changed SSML. We added an extra prompt. If you don't know what the combination is, say I don't know. And then we added a hint in case they don't say anything like that, to ask what's in your inventory if you'd like to know what the combination is. Because the inventory is written on a piece of paper that's in your inventory. Or sorry, the combination is written on a piece of paper that's in your inventory, but you might not have that piece of paper. But if you do, you should check your inventory. So by adding just a little bit of description here, we were able to increase that 80% to almost 95%, which by writing like, what, 6 words or something like that. So every word in your prompt, every sound in your SSML turns out to be really critical, and all those break tags, like where do you space out the conversation so that users can like catch up to you and make sure that they understood what you said. Every part of that voice output is critical for the users actually enjoying your application. So, as I said, so those are only 3 of the problems that we solved for the magic door. But there are three problems that all skills will have to solve. But beyond that, sorry. But that's just kind of the code part of the magic door. It goes inside of our Lambda function. And along with that code goes all of our stories, those 5,000 lines of story XML that we just keep adding to. That all goes inside of our Lambda, and we deploy that kind of continuously, as we'll discuss. But then beyond just that Lambda function, the magic door is a lot of other things too. We have code for running effects inside the story, like giving you inventory items, taking inventory items away, changing scene state when you pick up keys so that the next time we don't say there's a key there even when you already picked up the key, and things like that. So there's a lot of code. And then, as I mentioned, we do store inventory, scene state, user user preferences in DynamoDB. We spend a lot of time, as I mentioned, dealing with sound effects. So we store all of our sounds in S3, and we have some custom code for processing sound. We have backend workflows for creating stories and validating stories. And we have a website because, as I mentioned, the magic door is kind of too big to just show up at the crossroads and get 3 choices. You have to learn more about it if you want to fully experience it. We have custom analytics. You saw a little bit of that. And we're going to talk about some of these things as we go through. So this is how it's grown to be over time. So the next thing we're going to talk about is how we iterate on it now that it's live, now that we have customers. Now, it didn't start out this way. When we first launched, I was like zipping up files and uploading them to Lambda. But we kept at it, and that turned out to be just a huge headache, very failure-prone process. And by the way, like, only I could do it. My wife, she's writing stories at home. She's not an engineer, and we wanted her to be able to just kind of get her stories live pretty quickly. And so for all these reasons, it turned out to be important to do some continuous deployment. And so we do continuous deployment kind of the way a lot of people do continuous deployment, which is we check into GitHub. We have some kind of continuous integration thing that pulls from GitHub, runs your build scripts, and does stuff. And for us, our continuous integration product is Circle CI, which works really well for us. It was really easy to set up. It's free for our use case. One thing that we did at the beginning, even before we knew we were going to do continuous integration, was we built a lot of automation for our stories using Grunt. So what we do using Grunt is we do that compile step where we generate our interaction model. We validate our interaction model. We upload our interaction model to S3 so that we know what our current version is. We package up our code and its latest dependencies into a Lambda archive, and we upload them to Lambda. We do kind of a lot of things. We check for missing sounds. We run unit tests. Yes, unit tests are pretty important. OK, one of the things that we think is very general for all skills is the fact that the interaction model is like code, and you can screw it up in a whole bunch of ways like code. And so we wrote this tool just for us, but you can now get it from my Git repo, my GitHub account. And it makes sure that your interaction model is consistent and valid. And so some of the ways that you can screw up an interaction model are by having too many intents. OK, that's really only our problem. But you can also have missing samples, so no samples for an intent. You can have samples for an intent that doesn't exist. You can have the same sample for multiple intents, and maybe a few other things that I've forgotten. But this grunt task will check all of those things. So it's reasonably helpful to everyone. Now, I also mentioned that we deal with sound effects a lot. And at the beginning, we just kind of like, my wife would record it, and then she'd send me a file by email, and I would like run FFmpeg to convert it to the right format, and then I'd apply, I don't know, a big manual process. It was, it worked when we had like 10 sounds. But now we have hundreds of sounds, and we are always iterating on more sounds, fixing our sounds, things like that. And again, as a non-engineer, we wanted a way for her to just kind of like upload it and it would be live. So we kind of automated all that. And so now what we do is she uploads to S3 using just something on her phone. Any S3 client will do, into a private bucket. Any sound file, it could be WAV, it could be MP3, it could be whatever she comes up with. And we have a Lambda reactor to that S3 upload event. And that Lambda reactor, what it does is it pulls down the sound in whatever format, and then converts it to the ASC format, which is like MPEG-2 layer 3 at some particular bit rate, and then it uploads it again into a public bucket with public permissions. And then it's just automatically live. It takes about like 2 seconds or 1 second, or it's an unnoticeable amount of time, basically, to get a sound from her phone to live. And so that helps everyone. And yeah, so that's, by the way, and that's totally general for all skills. And so you can go to my GitHub repo and go use it yourself. It will take a little fiddling to get it to work the first time, but once you get it working, it just kind of keeps working. OK. So excuse me. So we shipped our code. We continuously ship our code. But we still want to make sure that it sounds good and it's a good experience. You can't really do that with unit tests. So you still have to go and you have to do voice testing. And a lot of people do voice testing like better than we do. Like you can have usability labs. You can hire like actual QA engineers. We don't do that because it's a side project. And so we have a couple tricks, though, that we think are pretty cool. So when we're doing voice testing, things go wrong. And it's a voice application, so things go wrong for a lot of different reasons, some of which are that speech is not understood correctly or not understood the way you expected it to be or something along those lines. So one thing that turns out to be really useful is to have an audio debug mode, like a speech debug mode for your skill, so that you can understand what it's doing and why. So what you can do inside the magic door is you can say, Alexa, set debug on anytime that she asks you a question. And then you'll start hearing like what intents Alexa's understanding. And so we use this a lot as we're kind of voice testing. There's not much code in that Git repo. There's basically an intent schema and a few samples. But you can use that in your skill. It's more like an illustration of how you do this than something extremely valuable that everyone must use exactly this code. OK, so another thing that we do is we want to continuously release our stories, even though they're not fully ready for prime time. But we just don't want a ton of users going to use them because they're not ready for prime time. So you can do this on the web. You can do this on mobile. But it's really easy to do this for voice because discovering things is difficult by voice to begin with. And in our skill, we just kind of like hide options. So when we're releasing a new story, we'll do something like this. Would you like to go to the mountains, to the sea, or to the portal? There are 3 options. Actually, there's a 4th option, which is crown, and crown takes you to the new story. Users won't say crown, so it's totally safe to just release that, and then go test it and debug it and send your family members through it and things like that, and see what goes wrong. So we do that a lot. That's I think we like that approach. That works well for us. We've also done other things like having gated experiences. It turns out that some users are really excited about your application, and they'll forgive you for almost. They want to feel like they're part of the development process. They want to feel like they're in it with you. They really enjoy that. We have some users like that, and so we have these like gated options for our most dedicated users, the ones who've completed all our other adventures, and they help us kind of make sure the story is fun, I would say. So we have released stories behind a literal gate, like literally, some people have gated launches. We have a literal gate with a key. So something that sounded scary to us at the beginning and definitely sounds scary to people all the time still is certification testing for Alexa. For us, what we figured out was that if we do all the things that I just told you about, certification for us is kind of like a minimum bar that we should definitely always meet without any question. And if we don't, then we've screwed up some other process that we should have been running better. I mean, certification checks things like, do you stop when the user asks you to? Do you provide help? Do your prompts ask a question? And as I mentioned, we've spent like hours obsessing over our prompts. Of course they all ask a question. We're like making sure that users succeed in our scenes. Of course they ask a question. So the certification bar is like this min bar. It's not this big scary thing where Amazon asks us to do things that we don't want to do. It's just, passing it is the outcome of us running the quality processes that we've come up with already. So there you go. Now, okay. So we release the story, we continuously release the story, we try to make it good before we launch it. But A, it's a voice application, and B, it's software. Really interesting things happen in production that you weren't expecting. So we spend a lot of our time just kind of watching prod and seeing in what ways it's working and what ways it's not, and then continuously improving. We have a couple ways of doing that. One way is we built this analytics system just for the Magic Door. It's kind of like a web analytics system, but not as good, basically. I mean, just to summarize. But it works for us. So what we know is that each of our scenes can fail in different ways. Like our app can fail. We can have bugs, we can crash, whatever. But each of our scenes can fail in different ways. Because they're like mini applications. Each one has choices. Each one has different things users can say. The prompt in each one influences how users will talk to us in that scene. So even if you get open the door intent right in other scenes, it won't necessarily be right in this particular scene. So everything fails differently, which is really interesting. So what we need to do to make our application work well for customers is to know which of our scenes and which of our stories is working well at any given time. So we built this analytics system to help us understand just that thing. And so this is kind of like a big eye chart, and you probably can't read anything, but it's okay, because what this does is it really helps you kind of drill in. And you can just say like, oh, they're red scenes. Red scenes are bad. Green scenes are good. That's the whole point of the visualization here. And so then you can drill in, and you can be like, oh, this scene is 80% successful, 20% not successful. And then you can kind of drill in farther by looking at the stream that backs all this up. And you can figure out what are users actually doing, how can we make that more successful? Can we change prompts? Can we add new options? Can we give them help, hints? What do we need to do? And so we're constantly looking at that, constantly. On a weekly basis, we generate a new one of those reports, and then we go find like the top 5 things that are not working that well, and we go burn it down. So the way this works is we, on every event in our application, we generate a little JSON message like this. We send it into CloudWatch logs, and then we export that to S3 and run some Scala code using Spark on an EMR cluster, and out pops that big old graph. So because we're doing it that way, we can actually do a few other things with that same stream. Like we have a CloudWatch dashboard that shows us some of our critical business metrics, and they're like up to date to the minute, and so we can use them when people say like, hey, I don't think your skill's working right now, and you're like, well, okay, I know it's at least up and we're not having errors. And also you can run alarms from your CloudWatch logs, and you can do a lot of things. We do a lot of things from our CloudWatch logs. This particular one shows story starts versus completions. If people are starting stories, we want them to mostly be, a constant fraction of the time to be completing them. And so we can watch this and figure out if we've introduced a massive bug into our stories. Okay, so we have analytics, great. But here's something that so when we launched, we really didn't know what to expect. We didn't know if anyone was going to use it, but what we did know was that we wanted to talk to our users about our skill. We wanted to know whether they thought it was fun, whether they were having problems, what they liked, because I would say that's all that we were getting out of the skill at that time. It's just like make people happy, be creative, make people happy. That's the whole point. So we wanted to talk to them. So we put up a Facebook page, on day 1, and no one came to it ever. So, but over time, as I mentioned, we've gotten a lot of a lot for us. It's a lot. We've got a lot of people to come to our Facebook page. And we talked to them about bugs. We talked to them about story ideas. One of our major stories was the result of us saying, like, hey, people, what kind of stories would you like to hear? And someone said, I'd like a Jack and the Beanstalk story. So we built a giant fern story. A little different, but kind of the same idea. That's how you get to the tower in the clouds, is by climbing a giant fern. So that's pretty much Jack and the Beanstalk, right? So we've gotten so much out of having a Facebook page, and it comes down to basically these things. One is we're not that good at building voice applications, and I don't think that's just us. I mean, like, as a group, we are not that good at building voice applications. Things go wrong. You don't anticipate all the possible utterances that people could make. You don't anticipate all the ways that they could get stuck or be unsuccessful in your application. So having a Facebook page that people know about is just this opportunity for them to just get unstuck. They come and ask you a question, you answer, you say like, oh, the magic word that you should know that we didn't prompt you about correctly is, crown or something. And then they're just on their way. So instead of giving you a 1-star review and going off and not liking your application, they're off on their way again, having fun inside the magic door. And so then that makes them happy. Then the other thing is, by having that discussion with users on Facebook, they talk to their friends about the magic door, and you get more customers. That's always nice too. And then over time, you build up this kind of big repository of answers to all the questions, like what are all the riddles and what are their answers. And people, when they get stuck, they can go there, get themselves unstuck, and keep using your app and have fun. So having a Facebook page, for us, this was one of our, I would say the big learning from our skill is you have to have, it doesn't have to be a Facebook page, you have to have somewhere where you can directly talk to your users about your skill. I don't know, you should feel obligated to do this thing as a skill developer. Okay, as I said, no one came on day 1, and why would they? Because they didn't know about it. We weren't driving traffic there on day 1. And so we tried a bunch of things when we started trying to get them to go to Facebook. The first thing was we put a card in the Alexa companion app saying, like, visit us on Facebook. And no one ever came to Facebook. Then we put up some signs, like literal signs inside the application, like at the crossroad, there's a sign. We were thinking that people would say, read the sign, because it's an adventure game, you should probably read the sign. But mostly they didn't do that. And when they did, they didn't come to our Facebook page either. So So that was not very effective either. But what we found out was that when you exit our skill, and when you exit any skill, actually, there's this opportunity at exit to say kind of whatever you want to say, and as long as it's short and to the point and doesn't, stop you from exiting, you can say whatever you want to say. And so in our skill, we have a few hints that we put at exit. One of them is for tips and tricks, visit us on Facebook at facebook.com/ALX305. Another is come back and play again. Another is leave us a customer review. I think we promote our new stories in those exit hints. So at exit, you can do whatever you want to do, and no one ever complains, and in fact, they apparently are happy about it. So as long as it's short and to the point. So this was, I feel like this is a learning that applies broadly. Go do something at exit. Okay. Now, once you get users talking to you on Facebook, now you have another problem. You have no idea who they are. You're there like on Facebook, and you know their name, and then you have piles of log data, like who in this pile are you? So we came up with this thing, which is if you say, Alexa, who am I, inside the magic door, Alexa will tell you who you are. You might be GXUQ5C. And then if you tell us on Facebook that you are GXUQ5C, then we can go look in our pile of log data and figure out exactly what problem you have been experiencing and where, and we can help you with it. So again, I mean, there's not a ton of code in that Git repo. There's actually an intent definition and some samples and a little bit of code that probably you wouldn't use, but you might. But you could use this. And you should do something like this in your skill. Like you should have some way of tying a customer that you find on your support site with what you're seeing in your logs. So what's next? For us, we're having a lot of fun building this, and so we're going to keep doing that. And we have kind of some things that we're going to try to do. One is analytics. We have better analytics than I think almost any skill. I don't know. A lot of skills. We have analytics, but our analytics are right now they're very basic. They're like scene level optimization. But what we really want to get to is really like customer interaction level optimization. Like we want to see how we can get more repeat customers, how we can get them to complete more adventures, how we can see like the workflow, whether they're completing kind of workflows like story flows. So we need better analytics. Another thing is the social aspect of our game has kind of surprised us about how effective and for us rewarding and for our users how useful it has been. And we kind of want to double down on that. And right now, we're just driving people to Facebook by having these messages. But we think that by using the Facebook graph APIs, we can kind of use achievements and sharing from inside our skill to kind of like get people to talk about it more, to get people kind of interacting more on Facebook. And I feel bad that I have not done this already. It's actually very easy to do. I have all the code. It's just so no excuses. This is like really important and interesting, and probably the next thing we'll do. And the next is scaling content creation. For us, creating content is basically very expensive, I would say. You have to pay attention to every prompt. And I'm not sure how we're going to scale content creation, but we would love to do that. And then finally, we work really hard. Users kind of like it. We feel like maybe there's money in there somewhere. Would love some of that. That is basically what's next. So, that's the magic door. We really have had fun building it. We think we've learned a lot that applies broadly to skill developers. You can, work backward from the customer, manage conversational state, obsess over SSML, test and deploy continuously, use your skill analytics, and go build a skill using using any one of our templates, but maybe the decision tree skill would be a good place to start. Thanks a lot.